And I wanted to start with the end of the activity, but this won't happen until next Thursday. I'm going to explain how you're going to get there. This is in an article that you have to read about dropping medicine into the Amazonian rainforest. I got tired of the egg drop activity because basically it was, does the egg break or not break? So I made it a little bit more quantitative as far as how you can determine success at dropping something. So this is the scenario that you're going to be trying to do well with. It's in the article. I'm just going to read it to you. Your medical company, a lot of things I teach, I put vignettes. I make up these vignettes to teach with. So your medical company's been given the challenge of dropping a rare liquid medicine, simple bicarbonate, into a remote village in the Amazon rainforest. Every villager requires this medicine to survive. Unfortunately, the liquid medicine has to be in continual sunlight. So that means it can't be covered up, and open air for it to remain effective. The villagers do not like modern flight technology. For example, helicopters, drones, airplanes, to land anywhere near their village. They have agreed to take the medicine if it can be dropped from above. Unfortunately, the medicine is environmentally hazardous. It's spilled onto the ground. It is also very expensive. Using a medicine cup, and I've got these little cups here, your company's job today is to test drop 25 milliliters of liquid medicine with minimal spillage. 25 milliliters is the normal adult dosage, and your group needs to realize every milliliter of spillage equals $100,000 in lost revenue. So we're going to drop them from the third floor far into the hallway. You don't have to do a parachute to do this necessarily, but that's what usually folks do. So what we're going to do today is study parachutes. I want to give y'all different variables to manipulate, where you're going to make a parachute and you're going to change something up to see how that affects how long it takes it to go from third floor down to the ground. And so I'm going to give you the directions for a standard parachute, and then we'll go from there. We're not doing this challenge today. That comes later. You're on your own when you do this. How are you going to drop your medicine? But I wanted to kind of show you the end before we start in the beginning. So let me turn this off now. So basically what we're doing is we're going to go from an experiment with parachutes. You're going to build a prototype based on the data we collect. You're going to test it where you can just drop water instead of this expensive medicine. Then you're going to move into the actual final apparatus to drop your medicine. So as far as the experiment goes, one thing that can be changed is weight. You could change the number of pennies that you put in your parachute cup. So let's have weight as one variable. You want to do that?
Sure.
So I want you to test, and I'm going to make you drop more than the other groups because you only got to make one parachute. The other groups got to make 3 parachutes. So if I'm going to make you drop more, I want to try to equal the workout. Drop it twice with 0 pennies, twice with 5 pennies, twice with 10 pennies, and twice with 15 pennies. You just time how long it takes to hit the ground. So 0, 5, 10, 15. Do you remember those pennies and how some of them are taped together?
Yes.
There's a reason for that, because they'll go all over the place when they hit the ground. So you want to tape up pennies. So what's something y'all would like to change?
Good question. Height.
I can assign it.
Height.
We're not going to change that.
How big the parachute is.
Parachute size, that'd be good. So parachute size,
problem.
Any group in here good with math?
Nope.
Not a single group's good with math.
What kind of math?
Simple, pretty simple math. Which one's good?
I can do fourth grade math.
Okay, well, I'll come help your group when I get to. All right, so parachute size. Basically, the chutes are going to be, one of the dimensions is 30 centimeters. So why don't you do a 15 centimeter, and I'll explain what this means shortly, and do a 45 centimeter, sort of proportional, and I'll explain what that means. What's something y'all can change?
Could you change the drop height?
No, don't do that one.
Change like the materials that make the parachute?
You could. That one generally doesn't show a real difference. I'll go ahead and tell you. Change your string lengths. So the chute string lengths are a standard 30 centimeters. Try shorter strings and try longer strings, 45 centimeters. All right. Tames. I want y'all to do shape, and I'll help you with this. So your standard shape is going to be hexagon. Do a square one and do a round one. And I'll explain how you can do that. So what's something y'all can change here?
What else is there besides like height or?
Number of strings. That one seems to make a difference.
Okay.
So change your number of strings. And the standard sheet's going to have 3 strings. So try 2 and 4 strings. To make the standard sheet, this is what all of you would make one sheet that's this way. Any of y'all sew in your lives? Yeah. Did you get your pattern at Walmart or something when they sold patterns? Well, at one time you'd go buy these patterns. Does anybody work for the Daily Mississippian? I made this joke one time and the girl got mad at me. We actually have a good use for this paper here today. This is going to be your template. This isn't going to be your parachute. This is what you're going to use to make your parachute. So on your Daily Mississippian, I want you to draw a rectangle right in the center of the paper, like this. It's going to be 15 centimeters by 30 centimeters. So you got a nice rectangle. At the midpoint, draw a vertical line, 10 centimeters, like that. Draw one right here at the midpoint. What would be the midpoint of 30 centimeters? 15, that's right. So then, you connect the corners here, like this. You're doing all this on your Daily Mississippian, right here. Draw you a nice hexagon, 6-sided figure. That's your standard template for a garbage bag. Our parachutes are going to be made out of garbage bags. So you can use this garbage bag courtesy of Caroline over there. And basically you'll, is this small?
No, it's folded in.
Yeah, all right, plenty. So you'll make your parachute out of this. Basically, you'll tape this plastic onto the paper and then you'll cut it out. That'll be your parachute. This will be your parachute. The newspaper will not be your parachute. It's just to help you be able to make a pattern. At one time, that's how you made dresses and stuff, was with a pattern when you sewed. So you follow how to do that? I'll follow how to do that. Okay. So, I'm gonna erase this now.
Well, wait.
Nope.
All right. So let's pretend we've gone from our newspaper to our plastic garbage bag here. Take a cup like this, one of these cups here. This is going to be, I guess they call this a gondola. This is what you're going to drop your sheet with. Put it right in the center. And so here's our cup, right in the center. You're going to make 3 strings. How far apart should your holes be with this? Carolina, we need a protractor too, I guess, for this activity. 360 degrees, how far apart should these holes be if they're going to be equidistant apart? Oh, no, not 90.
120.
120 degrees, your 3 holes. 120 degrees apart. So, basically you're gonna get you 3 30 centimeter strings. Like this. And if we have a hole here in our cup, and a hole here, that's about right there. With your hole punch, you're basically going to run a string through the hole, out the other side, and connect it there. Run a string right here. Tape it onto the plastic bag